For our next question, we'd like to prove whether this is true or false. Is the antiderivative of cos x squared sine x squared plus c. And so to begin doing this, we're going to need to find the antiderivative of cos x squared. So we're going to integrate cos x squared without bounds over dx. This is actually, the way that we do this is going to be different from the ways that you know how to integrate other functions, because we're not going to integrate by parts or by substitution. We're going to make this into another integral that actually has an integral identity, and that way we just have the integral identity in our answer. And so we have the integral of cos x squared. We're going to state that u is equal to root 2 over root pi of x. And so du over dx is just going to give us root 2 over root pi. And u squared is going to be 2 over pi x squared. And so for our x squared is going to be pi over 2 u squared. And so what that means is that we are going to be taking, here we're going to isolate dx is equal to root pi over root 2 du. So we're going to substitute our x squared in terms of u and our dx in terms of du. And so it will become the integral of cos pi over 2 u squared into dx, which is root pi over root 2 du. And this is actually going to become, once you pull out the root pi over 2, root pi over root 2, the integral of cos pi over 2 u squared over du. Okay, and then this is actually called a special integral, called the Fresnel integral. And that basically just states that so cx would be defined as the integral from 0 to x of cos t squared integrated over dt. And so that means that this integral that we have, so the integral of cos pi over 2 u squared over du is going to be equal to c of root 2 over root pi x would be the value of this integral. And so we're just going to plug that in here to get that the integral of cos x squared dx is equal to root pi over root 2 into c, which is the Fresnel integral, multiplied by root 2 over root pi x, and then we're going to have our plus c at the end. Obviously, this is not equal to sine x squared. Sine x squared actually has its own Fresnel integral, which is sx is equal to the integral from 0 to x of sine t squared dt. What this all means is that the question that we're trying to prove is false.